Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor Ajay Kumarkar, Engineering College, Ghaziabad. Today I am going to teach SLR parsing, second part. In the first part, we discuss about the what is the basic structure of the SLR parsing, and taking the some examples, I draw the conical collection item of the SLR parsing. After that, I discuss about the DFA of the conical collection of the item. Now, in the second part of this lecture, I am going to teach the previous one brief explanation of the SLR parsing. Then I take the another example of the SLR parsing. Then I draw the conical collection item of the SLR parsing. After that, I have draw the DFA, and then finally I conclude the SLR parsing table. Now, this is the basic architecture of the SLR parsing. In the SLR parsing, simply SLR parsing algorithm. Now, the final target is to draw the SLR parsing table. That is the combination of the action and go to. In action part, contain the terminal of the context free grammar, and in go to part contain the non-terminal of the context free grammar. In action part, there is a two type of the data are contained, that is the shift and reduce. And in go to part, we simply move from one state to another state. Now, these are the basic the definition of the how the SLR parsing is going on. In the first step, write the context free grammar and on the input symbol. Check the grammar is ambiguity. This is the second step. If the grammar is ambiguous, then that is very easy. We are not able to draw the context parse. We are not able to draw the context parsing table. And if grammar is unambiguous, then we able to draw the all these things parsing table and final outcome. Now, if we check the first step, then we move from the another step, that is we design the augmented grammar of a given grammar. After that, create a conical collection item of the LR item. That is the very important concept to draw the conical collection. We simply put the dot of every production rule. The fifth step, draw the DFA of the given conical collection item. And if DFA is complete, then we construct the SLR parsing table. With the help of the DFA, we construct the SLR parsing table. On the basis of the SLR parsing table stack, we finally conclude the final outcome. Based on the information that table, stack and parsing algorithm generate the final outcome. So these are the basic procedure for step for designing the SLR parsing algorithm. For the better understanding, we take a very simple example of the SLR parsing algorithm. Now, this grammar, first step, we check the ambiguity of this grammar. I have already explained that in ambiguity of the context free grammar, if grammar generate more than one LMD or more than one RMD, then grammar is ambiguous. So this grammar not generate the one LMD, more than one LMD and more than one RMD. So this grammar is unambiguous. So ambiguity. Now, what is the first step? We draw the conical, add the augmented grammar. What is the augmented grammar? Yes dash to yes and yes dash to AA and A dash to B. Now, this grammar is known as the augmented grammar. We add one extra production rule in a given context free grammar. Then this is known as the augmented grammar. What is the conical collection? Very simple. We put here star dot dot. This is the conical collection of the context free grammar. And what is the next step? Check the ambiguity. I will check it. Add the augmented grammar. Add the augmented grammar. The third step, a conical collection of LR item. Now, this is the conical collection of LR item. Now, what is the next step? Draw the DFA. And with the help of this, we draw the DFA of this context-free grammar. When we explore this context-free grammar, we shift this dot to the right side, and yes work as the input of this DFA. Now here is a yes is a input, and yes does to yes this. If dot comes in the last of the production rule, then this is known as the final state. And my target for all production rule, dot shift to the last. If dot shift to the last, then this finite automata has been completely designed. Similarly, we explore this one, we similarly explore this one. Now the first production rule has been explored here, and this is the final state. We explore this one. Now dot shift from here, A dot A. If dot comes any non-terminal, then we explore that particular non-terminal in this given state. Now we write the production rule. S tends to dot A and A tends to dot B. This is the another state of the this particular grammar. Now we need to explore this production. Now here, what is input? A, and A tends to A dot A. Again this process is repeated because dot comes A. Now we write the production rule of the A. It means A tends to A and A tends to dot B. This is the complete. Now we need to explore last one here and here. This is the B, and A tends to B dot. This state has been complete because dot comes into the last of the production. Now this is known as the final state. These two production, first and last, has been completed because dot comes to the last of the production rule. And if dot comes to the last of the production rules, then this is known as the final state. These two states are remaining. We have to explore. We've explored this first production rule. Now input is A, and A tends to A dot. If dot comes to the last, then it is also known as the final state. It is very simple to design the DFA of the any context-free grammar using conical collection of the LR item. Now we explore this one. If we explore this one, dot come here, and we need to explore the production rule of the A. If we explore the production rule of A, now this state will come. You can check it, no problem. Now we need to explore this one, this production rules. Now if we dot comes here, then input is he. Now this production rule is here. Now this is the DFA. This state has been complete. Now we need to explore further this state. What is this state? And A tends to A dot. Now this is your final state. If dot come last in the production rule, I've many times told that this is the final state. Now this production has been explained. If dot comes here, now we move from the another production rule. If dot come here, then same self loop will come. You can check it, no problem. If doubt, then in separate we can explore this production rule. If we explore this one, now this state has been come. You can check it. Now this is the completely finite automata or design of the given context-free grammar. Now if we count the number of states in this finite automata, that is I0, that is I1, I2, I3, I4, this is I5 and this is I6. Now with the help of DFA, we are able to design the SLR parsing table. And in SLR parsing table, there are the mainly two steps, two things are action and go to. In action, shift and reduce. In go to, the only the state are find out. In action is the collection of the terminal. In go to is the collection of the non-terminal. Now we can draw here the table. So now we can use to sorry. Now we don't need this one. Now here we are draw the SLR parsing table. Okay, now this is the this is I1. Yes. Now, what is the terminal? Terminal is A and B, and one more thing is dollar. And what is the non-terminal? That is yes and A. Okay. Now, these three things is known as the action. Now, these two things is known as the go to. And here is a state, that is I0, I1, I2, I3, I4, I5 and I6. Now this one is I0. I0 to yes, move to the I1 state. Now this is the I1 state. Now this is the S0. Yes, move to the state number 1. From I0, A move to the out I2 state. It means here is 2. Now from I0, here is I0. A move shift to the S3 state. Now here is a S3 and B move to the S4 state. Now the first SLR parsing table for the state I0 has been complete. Now from the I1 state, by default, I1 on check dollar, that is known as the accept, and nothing filled to the for the state I1. For the I2 state, we check all the terminal and non-terminal. For I2A, move to the state 5. From I2A, move to state 5. From I2A small a, that is move to the shift to the S3. Now this is here S3 and B, that is S4. Any movement or not, this state is also complete. Now we move another here, that is I3. From I3 capital A, move to the I6. I3 capital A, move to the I6. I3 small a, that is self loop, that is known as the S3, and B, that is here S4. From A, move here. I4, yes. For the final state, use for the reduction. For all non-final state is used for the shift operation. So now this is one is your final state. This one is your final state. This is used for the reduction. This is another final state. This is used for the reduction. This is also another final state. This is used for the reduction. Now, what is my grammar? Grammar is AA, and A tends to AA, and now A tends to B. That is R1, that is R2, that is R3. That is production R1 reduced from R1 rule, R2 and R3. Now, what is this one? This is the R3, and we fill R4, that is R3, R3, R3. This is final stage used for reduction, fill in all terminals. Now, we simply use for this, this is R1, and in R1 fill in I5 for all R1, R1, R1 for action table. From I6 is production rule number 2, and we fill to the R2, R2, R2 for all production rule. Now, this one is known as the SLR parsing table. And in this SLR parsing table, there is no kind of the RR conflict, SR conflict. So, we can also say that this is the correct grammar by which we can draw the syntax tree using SLR parsing algorithm. Okay, I think this is the best understanding for SLR parsing. We have another example for the better understanding to see this example, and in this example we draw the augmented grammar DFA. When we have DFA draw, then we move to the SLR parsing table. So now we can what is the S dash to S, S dash to A B, and S dash to B A B, and S dash to B A C, and S dash to A C B. Now A tends to A B A, and A tends to B, and B tends to B. Now this is known as the augmented grammar. We have one by one write every production rule. What is the conical collection of the item? We simply put here star, star, dot, 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 and dot. Now this is known as the conical collection of the item, and we apply the we shifting the dot to the right side, and if we shift here, then this one is the input. Similarly, follow this rule for all the production rule. Now this is R1, R2, R3, R4, R5, R6, and R7. There are the 7 different kind of production written in this example. For the better understanding, we give long example. Now that is very simple. Yes, yes, dash tends to yes. Now this is your final state, and we explain here. Here is a, and where is any kind of the A inputs? No inputs involved. That now this is the A, and yes tends to A and B. Now no further explore for this production, because this is the terminal. If it is the non-terminal, then we need to further explore this production rule. Now here B, now how many B? 1. Yes. Yes. We need to explore 1 production, 2 production, 3 and 4th production at same inputs. Now this is yes tends to B dot A and B. Yes production B dot A C, and remaining and this one B dot and B dot. Now these 2 production is shift operation, these 2 production is final operation. I think in this context grammar, shift and reduce problem has been occur when we draw the SLR parsing table. Now how many production has been covered? 1, 2, 3, 4, 5 and 6 production. Remaining 2 production are, that is A. Now S tends to A dot CB and A tends to A, B and A. Again dot comes from the non-terminal, then we need to explore the B production, that is this one. Now this one state has been complete. No. Now what is the next one? This is the A, no problem, A, yes, A, no one. Now A tends to here, S tends to A dot B, and remaining these 2 production also A, we write the S tends to B A dot B and S tends to B A dot C. Now this one this state, and this one state has been completed because dot comes to the right side. Now we need to explore this one state. Now here is a C inputs and S tends to A C dot B, and here is a yes, A tends to A B dot A. We need to explore the A production rule. So there is a 2A production rule. Here is a A tends to A B A dot and A tends to dot B. When we explore this production, I think this one is right, this one production is separate, and when we explore this production, then we find this one, that is the capital B. And what is this one? This one the B, and B tends to B dot. This is your final state. Now further we explore this one. Now here is a B, S tends to A B dot and S tends to B A B dot. Now this one has been final state, and C, S tends to B A C. This is again your final state. We need to explore this production similarly, same the procedure. Now if here this is the B and S tends to A C B dot. Now this is your final state, and here is a if we put here same state we find, that is A, and we put here we find the B. Now this is your final state. I think all state has been explored. Then we count the number of state used in this TFA, that is I0, I1, I2, I3, I4, I5, I6 and I7, I8, I9, I10. Total 10 number of states are concluded. With the help of the shift and reduce action and go to, we draw the SLR parsing algorithm. I think this is the best concept for understanding the SLR parsing algorithm. We next class we have meet the new topic, that is CLR parsing algorithm, and this concept is also very important for the GATE examination and other competitive examination. Thank you.